All right, thank you very much. Good afternoon, everyone. Thanks for coming to the afternoon session. Thanks, Bradley. That was really insightful. The king is action. I agree with you completely. I've had the opportunity to attend a number of these conferences globally over the last year, and having the chance to spend a lot of time talking to our customers, talking to a lot of different other suppliers and technology providers around the world. And absolutely one thing we know is that we are continuing to progress very well with our digital transformation, of course. However, today what I want to talk to you about is that we need to really take into consideration some of the human-centric elements to really accelerate that transformation. And to explain or give you some insight into my statement, I'm going to provide three stories. There's lots of elements around human-centric, human-centered approach to digital transformation, but I'm going to give you three stories. The first is about trust in AI. The second will be addressing the fears and, move to the side here, the fears and reluctance of operators in particular who are being monitored for the safety of their driving, collecting their data. How do you deal with that fear of having that information collected? The third is talk about one of the big challenges we have in our industry, and covered in part in the previous presentation. We have lots of data, but one of the big issues is, do we have the people and the expertise to actually turn that data into action and into something valuable? That's a real problem for our industry, and I'll talk to you about that as one of my stories as well. So I'm going to start with AI, and I'm going to talk to you about leveraging AI to reduce a very common problem in mining, which is ore loss and dilution. Depending on the resource, depending on the type of mining, this problem is more severe or less severe. But where it is a problem, ore loss and dilution can cost hundreds of thousands, if not millions of dollars per blast if you get it wrong. And so AI is actually a really great technology to help solve that problem. Let me just come back to that in a second. The image I've got here on the right-hand side of the screen, right-hand side, where I've labelled blast 1, that's a muck pile. I imagine most of you guys know that. That's broken material after a blast. Before that was blasted, it was a grade control model. Essentially, that's a data representation of an in-situ rock mass. That particular grade control model was broken up into 600 blocks of data. Those 600 blocks of data were equal to 45,000 data attributes. So when you blow up the in-situ rock mass into blast 1, as you see up there, you're effectively scattering your data set. So now as a geologist whose responsibility it is to now mark out where the ore and the waste is, this is a disseminated gold mine, by the way, in South America. So now you've blown up this rock mass, your data set is blown up. How do you determine where is your ore and your waste? Particularly if you visually can't see it. There's lots of other ways to do it, but it's a complex problem. AI is a really good way to solve that problem. Neural networks, AI is a really good way to solve that problem. And so one of the solutions that Hexagon provides, and I work for Hexagon, perhaps I missed that at the beginning, is a solution called Blast Movement Intelligence. It's an AI-driven model. It uses neural networks, because this is a complex pattern type problem, uses a physics-based engine to take lots of data pre-blast. So we take the grade control model, we take the blast design, explosives types, density of explosives, all range of manner of data for pre-blast. We take post-blast data, which is essentially the actuals. So we take survey data. We also have sensors we can put in blast holes to capture that information. Take all of that information, runs in the engine and creates something that's new, which is a muck pile block model. So this is something that not all mines have seen. It's something that's a little bit new to the industry, and it's part of our new technology, Blast Movement Intelligence, a muck pile block model. Essentially, it's a digital twin. So the geo takes that information, or the grade control geo takes that digital twin, and they can now start marking out where the ore and waste boundaries are going to be, where are they going to send the waste, where are they going to send the ore. But how do you get to a level of trust. It's an AI model. It's using a neural network. How on earth does that actually work? I'm not sure, but apparently it does. How do you build trust in that model? Well, there's a number of ways. Firstly, this solution, the AI-driven muck-pile model, has been proven at a number of mine sites around the world, and it's in operations. That's a given. The second thing, as a geo, when they look at this kind of information, this data set, they'll have a look at the grade control in situ block grade control model. They'll look at the muck pile model, and there needs to be a perfect mass balance between the two. And that is something that is delivered as part of this this technology, and it's a first step verification or validation that needs to happen. The third step, or the third level to help build trust, is to be able to interrogate the data. So we've heard about how we need good quality data. That was in the last presentation and heard from others. We need to be able to interrogate these models. And so with this particular muck pile block model, you can do that. Within a mine planning package, you can, in 3 dimensions, you can turn and rotate using your own human understanding, your training and knowledge as a geologist to actually see whether or not you think it makes sense. That's one aspect. The other then critical aspect is creating data integrity. This new muck pile block model is able to be connected back up through to the grade control model, every single data point back to the grade control model, to the resource model. The investment in creating that resource model in the first instance is significant for a mine, and now you can correlate that data all the way back down to this new type of block model. So that builds trust with the geo to start using this kind of technology. To run this model, it takes minutes. It's not hours, it's minutes. That's another benefit of using AI, also cloud-powered technologies to drive these kinds of engines. Another wonderful benefit that we've been able to see is that through having this high-resolution model, this muck pile model, you can actually stitch together multiple muck piles. Now you might wonder what that actually means and why would you do that? Well, in this picture here, blast number 2, that big pink bit along the middle of the screen, is a high-grade gold vein. Blast 2 was actually blasted before they'd finished, the shovel had finished mucking out the other high-grade gold, which you can see in the pink polygons. And some of that pink material in blast 2 landed, broken rock, on top of blast 1. So what do you then do now? How are you going to figure out where you're going to draw your ore and waste boundaries if you can't visually see it? Well, you create a new muck pile block model. You stitch the two together, and again, you go through the same process. Interrogation, being able to validate it back up to the grade control and resource model, and you have all that data integrity managed. So this is one of the ways in which AI you start to be able to trust AI. Being able to have the ability to validate, verify, and manage the data set. Okay, which is summarised there. All right, so the next story I'm going to talk to you about, and actually another one of Hexagon's solutions, also uses neural networks, by the way, is Hexagon's operator alertness system. I'll just explain or show you what that is. In here you've got a haul truck driver, and our system is monitoring his eye closure. And the reason we monitor the eye closure is still the #1 indication of fatigue. Researchers continue to prove that is the #1 indication of fatigue. So we call it PERCLA. Eye closure, actually I can't remember exactly the acronym, but anyway, as the eyes close, we know that there's fatigue starting to occur. So in this instance, you can see that just as that little highlighted section in the middle, the two little sections go red, his eyes are starting to close. There's actually a second part of this video that I haven't shown you, and that's when he falls asleep. His eyes fully close and he starts to turn off the road. Fortunately, OAS is able to capture that moment, alert him through alarms and seat vibration, and he course corrects, and he has avoided what could have been a very nasty incident. We know in our industry that fatigue and distraction is the #1 cause of incidents for mobile equipment in mining. We know that. And it's obvious when you watch these types of technologies or watch this video, the benefit is obvious. However, When you put a camera in a haul truck and put that in front of an operator, they're not particularly happy because now they're concerned that their driving ability or the way in which they act is being monitored. Data is being collected about themselves, and that's quite confronting. And in some areas, sometimes they may fear for their job, their livelihood, if they were to do something wrong. You know, we see all kinds of things happen where we see operators try and pull cables out of the back of cameras. We see all kinds of ways trying to avoid it because they're fearful of it. So how do we address that concern? There's a number of ways, but one of the more positive ways we deal with this is through sharing the numbers. But before we share the numbers, actually we make a general principle, an understanding of principle that everyone experiences fatigue events. Everyone in this room would have experienced fatigue events, whether it's in a serious environment like driving a haul truck or whether you're sitting in a conference and listening to someone's boring presentation. We all experience fatigue events. So this is the kind of numbers we share. This is a site actually we implemented in Australia about 12 months ago, actually last year. Within the first 3 months, we identified that it was 1,375 fatigue events. So this is your eyes starting to close across the haul truck fleet. That's a pretty high number, pretty scary number. And the advantage of showing that number to the crew is they go, well, it's not just me, it's actually everybody. Wow, we really have a problem we need to resolve. A year later, that number reduced by 53% to 653. That's a significant drop in fatigue events. But it's actually this next stat which is most important and most compelling. It's the reduction in severe eye closure or severe fatigue events. And that's when your eye closes more than 50% for longer than 4 seconds. So in the first 3 months, that was 338 times that occurred at this particular mine site. After 12 months, that's dropped to 68. So now we are helping the operators be far safer for themselves and also their peers and the mine in general by having this system in place. We've deployed this solution at hundreds of mines around the world, and some of the best stories we hear is when the mines really take on board their responsibility for working with the operators around fatigue. When you have outliers, and we have examples of this all the time, outliers of operators whose fatigue is far more consistent than others, we've been able to, or the mines have been able to determine that these people have undiagnosed medical conditions, sleep apnea, in some instances diabetes. And so the mine then works with those individuals to help them with their medical condition and help them get back to be working and not have those fatigue events. They continue to earn an income and they continue to be safe. So that's some of the wonderful stories of being able to take a positive, human-centric change management process for what can be quite an intrusive technology if you don't think of it in that way. All right, my last story, and this impacts mines around the world. Not all mines, but many. Access to people, talent, expertise, particularly in the world of data and analytics. So, referencing again the last presentation, you know, the king is action. Well, what if you don't have anyone who can take action or help you get to action, do the analysis, go and actually clean the data? What do you do then? And so at Hexagon, we have worked with many of our customers out of what we call our smart centres. And we have a number of smart centres around the world. And the one I'm going to talk about in particular, which is this chap here sitting in Indonesia, in Balikpapan, which is a wonderful way of us engaging a great array of talent that is in that region. Mining engineers, data engineers, domain experts. For example, we have domain experts in fleet management. We have domain experts in scheduling. And so one of our customers in Indonesia actually published this information. I won't share their names. They did publish it it's on their website. They came to Hexagon, and we've been working with them for a while, and we're talking about a mine expansion, quite a significant mine expansion. And they'd done their numbers, and they were a bit concerned because it was going to require, they believe, 25 new haul trucks. And they came and asked us, we don't have the people, we need some help understanding of whether or not that number is right. Using our domain expertise or our people in Balikpapan, using domain expertise, understanding of fleet management, data analysis, data engineering. We're able to work with that client, that customer, and we help them understand they didn't need 25, they needed actually 10. So reduce their haul truck fleet or their potential new haul truck fleet by 15, which, times that by the cost of a haul truck, that's a big number. And so that's something that we're really proud of, and it really shows that being able to have these, located centres in various parts of the world, we can really contribute to the digital transformation for many of our customers. And I'm going to touch on one last story. I like this one because it's nice and simple. It's around our safety analytics or safety data that our experts were reviewing and working on with customers. So they're proactively looking at data for our customers. In this instance, it was about collision avoidance. So our collision avoidance system, and looking at the alarming across their site, seeing where there was anomalies, where there was improvements. And what they determined, I'm going to show you a picture which we mocked up because we wanted to keep the privacy and confidentiality of the mine. But what we discovered, or what not I or we, but the guys in the Smart Centre discovered, was that there's unusual alarming on a relatively straight haul road. And so when they dug into that, they realised that the haul roads were actually, there shouldn't be that many alarms because it's quite straight, right? So they determined that actually the road was too narrow. That's got two problems. One, it's obviously a safety problem. Second is obviously in that jurisdiction potentially could have been an issue around their compliance to haul road construction. Anyway, they resolved that and resolved two big issues: safety and also potentially impact on their operations. And so that's it. The stories really is, how do we take human consideration into this digital transformation? What are the things we need to think about? There's lots of things. At Hexagon, we have that as front and centre in the way we work with our customers. And hopefully I helped you kind of understand a few. One was trust in AI, building trust in AI, building trust in operators when you've got things like data monitoring them. And the third is, how do you take advantage of expertise and resources when you just don't have it, particularly around data and analytics. So thank you very much for your time. I'll be at the Hexagon booth if you want to have a chat, or come and grab me and we can talk more. Thanks very much.